Hello everyone, welcome to EkEdu. So today we are going to study a new law, that is Hess Law, but before that we should understand thermochemical equation. What do you understand by thermochemical equation? What do you understand by thermochemical equation? See what happens when we have a balanced chemical reaction, right, with its enthalpy of reaction, then we call it a thermochemical equation. Suppose we have this reaction, just a minute. Suppose we have this reaction with us. C2H5OH, that is alcohol in liquid state, reacts with O2 gas, right? We get twice of CO2 gas plus thrice of water, that is liquid. So in this case the enthalpy of reaction will be minus 1367 kilojoule per mole. Yes, so basically this is a thermochemical reaction where we know the values of enthalpies of formation, and with the help of them we can calculate enthalpy of reaction, and thermochemical equation is that reaction where we have the balanced chemical reaction. Now suppose if you reverse in a thermochemical reaction, if we simply reverse this equation, right, if we simply reverse the equation, like if I write it like this, twice of CO2 gas plus thrice of water, on simply reversing the equations, what will happen? We will get ethanol plus oxygen gas. So the enthalpy of formation or enthalpy of reaction will become positive this way, 1367 kilojoule per mole, right? Basically on reversing the sign, when we are reversing the sign, the enthalpy of reactions also when we are reversing the reaction, the sign of enthalpy of reaction also reverses. Basically the first reaction is exothermic in nature, so the reverse reaction will be endothermic, right? Now another point you have to remember in this case is, suppose for example you have this equation, we have Fe2O3 solid plus thrice hydrogen gas will give us twice of Fe solid plus thrice of H2O liquid. This is the chemical equation. Now suppose they have given you the enthalpy of formation of Fe2O3, it is minus 285.83 kilojoule per mole, minus 285 minus 285.83 kilojoule mole inverse, and we have enthalpy of formation of wait, just a minute, let me write actually this value is for water, right? The enthalpy of formation of water liquid is enthalpy of formation of Fe2O3 solid is minus 824.2 kilojoule mole inverse, and we know that as per convention oxygen gas and iron solid, they are present in the standard states, so the enthalpy of formation of iron solid will be equal to 0 and enthalpy of formation of H2 gas will be equal to 0. So using this data, we have to calculate the value of enthalpy of reaction. So products, so it is enthalpy of product, that is 3 minus 285.83 minus Fe2O3, that is minus 824.2, right? This is what we get. On solving this, you will get minus 857.5 plus 824.2 is equals to minus 33.3 kilojoule mole inverse. Yes, for this reaction. Now suppose if we divide the whole equation by 2, simply divide half of Fe2O3 solid plus 3 by 2 of hydrogen gas will give you Fe solid Fe solid plus half of, that is 3 by 2 of H2O liquid. Now what happens? Enthalpy of reaction. Yes, so we have to find out the value of enthalpy of reaction. It will be 3 by 2 of minus 285.83 minus half of minus 824.2. So on solving this, you will get minus 16.6 kilojoule per mole. So if you just compare the values or results, it's just half. So we can say that enthalpy is an extensive property, right? And you have to remember these two results. Enthalpy is an extensive property. So you have to remember these two results. Number one, that on reversing the equations, the signs of delta H will also reverse. And second is that if we multiply or divide the equation by any number, the value of delta H will also change. Now the next topic and the most important topic of this lecture is Hess Law. We have to discuss about the Hess Law. So Hess Law, like suppose we have a chemical reaction A is to B and we have to find out the value of delta H for this reaction. Now suppose A is converting into C and C gets converted into B. Now the value, first equation delta H1 and for second we have delta H2. Now on simply adding these equations, on simply adding these reactions, we'll get our net reaction. So the value of delta H will be delta H1 plus delta H2. Yes, right? Suppose we have this, suppose we have this question like carbon solid plus half oxygen gas will give you CO, that is carbon monoxide gas, and the enthalpy of this reaction is minus X. Now CO gas plus half O2 gas will give you CO2 gas, and the enthalpy of this reaction is minus Y. Now the question is, they ask you find out the value of delta H. Find out the value of delta H for this reaction, and the reaction is, this is the carbon solid plus oxygen gas gives CO2 gas. CO2 gas. CO2 gas. So what you can do is, if we simply add equation 1 and 2, simply add these equations, this right, the CO and CO, they will get eliminated, and we will get carbon solid plus oxygen gas will give you CO2 gas. So the value of delta H here is, it will be minus X and minus Y. Right? Yes, so it will be minus Y. So the value of delta H is minus X plus Y. This is how we calculate the value of delta H. Right? Now, suppose we have another question like, we have this question, Fe2O3 plus 3CO. I'm not writing the states, okay? Or okay, I'll write the states so that it will become more clear to you. Okay, so it's Fe2O3, and we know that it's solid, it's understood. 3CO gas will give you twice of Fe plus 3CO2. This is gas, this is solid, and suppose this is equation 1, and the value of delta H is equals to minus 26 kilojoule. Next we have FeO solid plus CO gas will give you Fe solid plus CO2 gas. So the value of delta H2 is minus 16 kilojoule. And suppose this is equation 2. Now find out, the question is find out delta H for the reaction. Now the reaction they are giving to you is Fe2O3 solid plus CO gas minus gives you twice of FeO plus CO2 gas. So now Hess law, according to Hess law, what we can do, we need this equation as our resultant. So we can multiply, divide, add or subtract equations 1 and 2 in such a way that the net result is this, right? Fe2O3 is the reactant, yes, left hand side, and CO, we need CO gas. If we simply add these two equations, we'll get 4 moles of CO, but we need only 1 mole of CO. So what can we do? We need only 1 mole, so we cannot add this. And just check the equation. This is FeO, and we need 2 moles of FeO. This is CO2. Yes, if we add, we'll get 4 moles of CO2. If we'll subtract, we'll get 2 moles, but we need only 1 mole, and we need 2 moles of FeO. So if we multiply this equation by 2, suppose I'll write on the next page, I'll write both the equations again. This Fe2O3 plus CO gives you twice of Fe plus 3 CO2. In exams, you don't have to write the equations again and again. What you can do, you can simply add and subtract them in your mind. This is very simple. This is not a very tough thing to do. Twice of Fe plus twice of CO2. Yes. Check the equations. You can check it. Right now, if we subtract, these questions we do only by hit and trial method. We have to try. We have to keep on trying. Like whether we have to add, subtract, multiply an equation with a number, divide an equation with a number. So we get, see, Fe2O3. This gets cancelled. We get Fe2O3 minus twice of FeO plus CO will give us CO2, right? And if I take this FeO on the right hand side, we'll get Fe2O3 plus CO will give us twice FeO plus CO2. Yes, so this is the, right? This is what, this is our net equation. So now we have got our net equation. Now we have to play with the values of delta H1 and delta H2. So delta H will be delta H1 minus twice of delta H2. So delta H1 is minus 26 and minus 2 into minus 16. So it will be minus 26 plus 32. 16 to the 32. So on solving, you will get plus 6 kilojoule per mole. Yes, this is the answer. 6 kilojoule per mole. This is how we do questions related to Hess law. Okay, I'm giving you a question, and in the next lecture we will be discussing this question. So you can take this question as a homework. So the question is, find the enthalpy of reaction, and they are giving you the reaction. Find the enthalpy of reaction. The reaction is C2H6 plus 7/2 O2 gives us twice of CO2 plus 3 water. So we have to find out the value of delta H for this equation, right? If the enthalpy of formation, if the enthalpy of formation of C2H6, CO2 and water are minus 20 kilocalorie, minus 90 kilocalorie, and minus 70 kilocalorie. So you have to find out the value of enthalpy of reaction of this for this equation, right? So you can try this by yourself. In the next video, I'll be solving this question for you. Thank you so much.